Right, let's look at buffer solutions in this video. A buffer is a solution that resists changes in pH when a small amount of a base or an acid is added to it. Okay, so if at any point if we want to keep a constant pH, we then have to create buffer solutions, and we do that by adding either a weak acid to its conjugate base or a weak base to its conjugate acid. So those are the two types of buffer solution that we've got. Remember in the previous lesson, we looked at the different types of buffer. We said we've got an acidic buffer, which is made up of a weak acid and its conjugate base. Example, ethanoic acid and sodium ethanoate. And alkali buffers, which consists of a weak base and its conjugate acid. Typical example is the ammonia and ammonium chloride. So that's the definition of a buffer, a solution that resists changes, slight changes in pH when we add either an acid or base, little bit of an acid or base to it. Now, if you put too much of either of them to it, it will overwhelm it and the pH will change. And so let's look at how buffers work to prevent changes in pH. So let's take our acidic buffer. So we got our acidic buffer, we got ethanoic acid, it's salt in it. Now if we add an acid, in which case we'll be adding H+ ion, in order to prevent the pH from changing, the additional acid that is coming in needs to be dealt with, i.e. it needs to be mopped up of the system. Otherwise we will end up having a buildup of H+ ion concentration in the solution, and that will cause the pH to fall drastically. And so we have to have a way of mopping up any additional H+ ion that comes in to the system. So when we add an acid, let's say we take a drop of hydrochloric acid and put it in the solution, that will be taking over, will react with the salt component of the buffer. The sodium ethanoate will react with it, producing ethanoic acid and sodium ion, so that in doing so we will not have buildup of H+ ion in the system, causing the pH to drop. So every additional H+ that comes in is taken by the sodium ethanoate. Okay, now what then happens if a base or hydroxide ion is added to the solution? In which case the hydroxide ion that comes in will react with the acid component of the buffer to produce ethanoic ion and water. Any base or OH that comes in is mopped up by the acid, and in so doing we will not have a buildup of OH ions in the system, which will cause the pH to increase. So we have two systems, one that mop up any additional H+ that comes in, and the other that mop up and every OH ion that comes in. And in doing that, we manage to maintain the pH at constant range.